Let's talk about motor pathways in the peripheral nervous system. Really, we want to emphasize the autonomic nervous system, but I want to compare and contrast the two, so that's why I'll say peripheral in general, all right? Let's think back to what we looked at all the way back to the neuromuscular junction, okay? So we had a cell body, all right? And that cell body sent out an axon, and it sent it to a skeletal muscle, right? All right, so let's see. Oh God, this is scary. He's drawing. Watch out. All right, so we've got a receptor here, and this is supposed to be a skeletal muscle. All right, just shut up. All right, it's fine. It's good enough. So let's think about what was going on with this neuron here. Where was the cell body? Cell body was in the ventral gray horn of the spinal cord, okay? Cell body in the ventral gray horn of the spinal cord. And the axon, remember, was myelinated, all right? It was the type A fiber, the really big one. So it sent it out here, and it then had a synapse. This would be the neuromuscular junction right here, where the somatic motor nerve synapsed with a skeletal muscle, all right? So that was the somatic nervous system. And we can go ahead and identify that as the somatic nervous system, the SNS, all right? Somatic nervous system. Well, now we're going to switch over. We're going to look at the autonomic nervous system. And remember, the autonomic nervous system has two distinct divisions, all right? There is the sympathetic. I'm just going to write symp for sympathetic. I think you can deal with that, can't you? Yes, you can. And parasymp for parasympathetic, all right? Let's see what happens in this case. In this case, we have an axon, all right? And we have a cell body. And it's only going to go a little ways and then synapse with a second cell body, and that will go out to the actual organ itself. Now, there are lots of different possible organs that this could be dealing with, right? All of your internal viscera. So I'm just going to draw some kind of thing that, who knows what that is? Liver, pancreas, you name it, all right? Lungs, heart, anywhere out there in your body. Now, what happens here in the autonomic nervous system, is that the first axon is myelinated and the second one is not, all right? And furthermore, whereas this came out of the ventral gray horn, in the autonomic nervous system, this cell body is in the lateral gray horn. Remember, there was the dorsal gray horn and the ventral gray horn, and this is in between, in the lateral gray horn, all right? Now, what's going on here? This is kind of like, like the power, you have the power, the big power station, and then they're like substations. This is kind of like a substation. This is where I'm only drawing a single axon and a single axon, but in fact there would be bunches and bunches and bunches of them. So this would actually be a big, massive collection of cell bodies somewhere out in your peripheral nervous system. Remember, what is the name for a collection of cell bodies in your peripheral nervous system? This is a ganglion. Right? A ganglion. Now, we can name these two axons in the neuron itself, really, in the axon. This is the preganglionic, and this is the postganglionic. Okay? Not hard. They're just trying to describe where they are. This is the axon before the ganglion. This is the axon after the ganglion. These terms get used a lot, so get used to them. We'll be talking about the preganglionic neuron or axon and the postganglionic. It's not difficult, easy terminology. It's just telling you where they are. The preganglionic and the sympathetic are always myelinated, and the postganglionic are never myelinated. Okay? So there you go. So, having cluttered that all up, let's get rid of all that and look at the parasympathetic. Parasympathetic in a lot of ways is similar, but it's also different. Oh yeah, that's profound right there. So it's going to look more like this. And once again, this is some organ out here. Who knows what it is? Doesn't matter. It's heart, lungs, liver, pancreas. Nobody knows. Doesn't matter. It's all of them, all right? So once again, the preganglionic is myelinated and the postganglionic is not. Right? Now, what do you see? What's a difference here that seems obvious? What is the difference here? Yes, that's right. So in the sympathetic, we had a short axon followed by a long axon. And in the parasympathetic, we had a long axon followed by a short. So what does that mean? Once again, this is a ganglion. You're going to have to know these ganglia. So for example, sympathetic ganglia include the sympathetic trunk ganglia or chain ganglia, the inferior mesenteric ganglion, superior mesenteric ganglion, the celiac ganglion. Parasympathetic, we'd have like the submandibular ganglion, the otic ganglion. Those are just some of them. There are many more. So what's happening here is in the case of the sympathetic nervous system, the ganglia are close to the spinal cord. Remember, these are coming out of the lateral gray horn of the spinal cord. So these ganglia are close to the spinal cord. The second axon then has to go sort of a long way to get to the organ itself. Whereas in the parasympathetic, the ganglia are not anywhere near the spinal cord. The ganglia are actually out near the organ, so that the second axon only has to go a tiny distance from the ganglion to the organ itself. So I think that's just, in order to keep it cluttered up. If you had all the ganglia right near the organ or right near the spinal cord, then they would all be, on top of one another and stuff. So your body figured out a great way to do it. Have the sympathetic ganglia right near the spinal cord, make the parasympathetic out near the organ itself, okay? So we've got the basic pathways. There's one exception, all right? There's one big exception here that we want to make a note of, all right? And that is in the sympathetic nervous system. So it's time for you to come back into the game, buddy. Get off the bench. All right, so the sympathetic nervous system at the adrenal medulla. So medulla, we haven't really looked at. The adrenal gland, a lot of organs have both an inner part and an outer part, the medulla and the cortex, all right? So the medulla is the inner part, the cortex is the outer part, all right? So the adrenal medulla is actually basically a sympathetic nervous system ganglion. What it does is it sends one axon all the way out to the adrenal gland. We'll draw that in a different color if I have a different color. This is kind of a different color. So this would be the adrenal gland, all right? That's the adrenal gland. And it is myelinated all the way there. So this is the one big exception. Sympathetic has this one exception where it talks to the adrenal medulla using only one axon and it's myelinated. All the other sympathetic look like this, okay? Now then, let's talk about the neurotransmitter. We already know the neurotransmitter at the neuromuscular junction, don't we? This is acetylcholine, okay? And as it turns out, this neurotransmitter right here is also acetylcholine, and this neurotransmitter here is also acetylcholine, and this neurotransmitter here is also acetylcholine. Holy smoke, can we make it any simpler than that? All the neurotransmitters in the autonomic nervous system and sympathetic are acetylcholine, except for this guy, all right? All the others are acetylcholine. Who is this guy? This is the different one. This is norepinephrine. And let me talk about the word norepinephrine. So epinephrine is the same as adrenaline. They're the same chemical, all right? The same molecular chemical substance. In this country, we tend to use the word epinephrine. In Europe and on TV and in movies, they say adrenaline, all right? But in the hospitals here, and they're going to say epinephrine. So adrenaline and epinephrine are basically the same thing. Well, I mean, they are exactly the same thing, sorry. And then epinephrine and norepinephrine are basically the same thing. So if you think about this as being adrenaline, you're close enough for government work, okay? It'll work out, all right? So just think of this as adrenaline, because that will remind you that these are a certain kind of receptor. So I'm going to erase this bottom one because it's going to get in the way of what we're going to do next. Normally I have a couple of whiteboards that I do this on. There's plenty of room, but this little tiny whiteboard just doesn't quite cut it. Okay, so those are the neurotransmitters, all right? 1, 2, 3, 4 of them are acetylcholine. One of them is norepinephrine. Easy to remember. Just remember they're all acetylcholine except at the organ for the sympathetic. Sympathetic, adrenaline, norepinephrine, virtually the same thing. Let's look at the receptors. So the receptors, for acetylcholine, there are two kinds of receptors. At the neuromuscular junction, it's a nicotinic receptor. Nicotinic. Why is it called that? Because nicotine is an agonist at this receptor. You don't normally have nicotine in your body, unless you smoke cigarettes or do chew or whatever. But in other words, normally you don't have nicotine. It's just that this receptor will not only respond to acetylcholine, it will also respond to nicotine. So we call it a nicotinic acetylcholine receptor. Turns out this receptor is also nicotinic. And this receptor is also nicotinic. Look at how easy it is so far, all right? So acetylcholine was the neurotransmitter at 4 out of the 5 places, and nicotinic is for the somatic nervous system. It's also at the ganglia in both divisions of the autonomic nervous system. So where's the only ones that are not nicotinic? Right at the organ. Right at the organ for the sympathetic and right at the organ for the parasympathetic. Now, right at the organ for the sympathetic, we call these receptors adrenergic because they respond to adrenaline, which is essentially the same as norepinephrine. These are adrenergic receptors. And at the organ in the parasympathetic, we could call these cholinergic if we wanted to, but actually the nicotinic are cholinergic as well. So I'm going to discourage you from thinking about it that way. I want you to think about this receptor as being muscarinic. Why muscarinic? Well, muscarine is a compound found in nature that will also bind to this receptor. So this is a receptor for acetylcholine, but muscarine will also activate this receptor. So you can see the only big differences here are at the effector organ, the target organ. And this is where we're going to be focused. When we deal with the autonomic nervous system, this is our focus right here. So all of this was just kind of to show you the way it's set up. But this is where our focus is. We're going to be talking about the sympathetic nervous system as releasing norepinephrine onto adrenergic receptors. And we're going to be talking about the parasympathetic releasing acetylcholine onto muscarinic receptors. And then unfortunately we're going to see that there are a couple of examples in the sympathetic where it breaks the rule, but we'll talk about those. But if you remember, this is the general basis for what's going on. And once again, this is where we're going to be spending most of our time and attention, right here, all right? This is where we're focused. Sympathetic releases norepinephrine onto adrenergic receptors. Parasympathetic releases acetylcholine onto muscarinic receptors. Get that solid in your head and you'll be good to go.